Hello student, welcome to our lesson 4. In this lesson, we are going to do several numerical problems involving electrical energy and electrical power. So we start with the first one. What is the maximum number of 100 watts bulbs which can be safely connected from a 240 volts source supplying a current of 5 amperes? We proceed as follows. We first of all need to get the total power supply, and this is given by power is equals to voltage times current. Now our voltage is 240, then we multiply by current, which is 5. When you do that, you get that it is 1200 watts. That is the total power supply. Now let the total number of bulbs be n, because now we want to get the number of bulbs. Remember, one bulb is taking 100 watts. Therefore, the total power consumed by the bulbs will be equals to 100 times n. Now, 100n will be equivalent to 1200 watts. Now, for us to get the value of n, we divide through by 100, and when you divide 1200 divided by 100, you get that n is equals to 12 bulbs. So first of all, get the total power. Then number 2, divide by the power of a single bulb, and that way you're able to get the number of bulbs that can be safely connected. Then number 2, an electric bulb is rated 60 watts, 240 volts. Determine the resistance of the filament. Then number 2, the current flowing through the bulb when it is connected to the mains supply. We proceed as follows. We have seen that power can also be calculated by V squared of R. We have V, we have power, we have only R as our unknown. And therefore, substituting the values, we have power, which is 60, is equals to 240 times 240 divided by R. So making R the subject of the formula, it will be 240 times 240 divided by 60. And when you do so, you find that R will be equals to 960 ohms. Then number 2, you're supposed to get the current flowing through the bulb. We know that power can also be calculated using voltage times current. And therefore, from this formula, we can make current the subject of the formula, where we divide through by V, and therefore I will be equals to power divided by V. By so doing, you get power, which is 60, that is 60 divided by 240, which is our volts or voltage. You get that our current will be equals to 0.25 amperes. Then from there, we move to question number 3. The circuit diagram below was used to light 3 voltage 0.5 amperes bulb from 12.0 voltage DC supply. Determine the rate at which electrical energy is converted into heat energy in appliance R. So we have this, we have our bulb, we have this as our R. So we proceed as follows. First of all, we always write the formula. Remember, we are saying you must be systematic. Start with the formula. Power is equals to voltage times current. We have the voltage, we have the current. So by so doing, or by multiplying, you get that the power is 60 watts. So that way, you get that the power, because now we are supposed to determine the rate at which the electrical energy is converted, and the rate at which the energy is converted is what we call power. So power is equals to 6 watts. Then number 4, a wire made from some alloy has a resistance of 2 ohms per meter, which means that in every meter we have a resistance of 2 ohms. So what length of this wire would require to make a heating coil of rating 240 volts 1 kilowatt? So first of all, we need to get the resistance of this wire. And we know that power is equals to voltage of a resistance. We have power as 1 kilowatt, which is 1000 watts. We have voltage as 240. So we can be able to get the resistance by dividing 240 times 240 divided by 1000. And by so doing, you find that your resistance is 57.6 ohms. But from here, we have that 1 meter is equivalent to 2 ohms. So how many meters are there in 57.6? So you divide by 2 ohms. You find that the length will be 28.8 meters. Then we move to number 5. A total charge of 360 coulombs is passed through an 80 ohms resistor in 30 seconds. Determine the amount of heat energy generated. Now this one, you find that current is given by Q over T, because current is the rate of flow of charges, and therefore current is given by the number of charges divided by the time T. Now the charges are given as 360 and the time is 30 seconds. Therefore we can be able to get current as 12 amperes. But our question, we are supposed to get the amount of heat energy. We know that heat energy is given by I squared RT. Now that we have I, we have R, and we have time, we can be able to get now our H. So we multiply 12, that is our current, 12 squared, then multiplied by 80, that is our resistance, then multiplied by 30 seconds. When you multiply that, you get that the energy or the heat energy generated is 345,600 joules. So this is the energy that is being generated. Then number 6, when a current of 2 amperes flows in a resistor for 10 minutes, 15 kilojoules of electrical energy is dissipated. Determine the voltage across the resistor. We proceed as follows. Heat energy, H, is VIT. So 15,000 joules is equals to V, that is what we are looking for, multiplied by the current, multiplied by the time. And in our time here, remember we are talking of 10 minutes. So we have to convert that into seconds by multiplying with 60. So making the subject, or V the subject of the formula, you find that it will be 15,000 divided by 2 times 10 times 60. And by so doing, when you divide, when you key in your calculator, you find that the voltage will be 12.5 volts. Then from there we have the assignment. I'm sure that has given you enough practice. And it is always necessary that if you have not understood, go back, listen, redo, discuss with your peers, and then come and attempt the assignment. After this assignment, prepare for the end of topic exam. So thank you, and let us meet in another topic.